Hi, friends. I decided to share another example with you. It's a bit different from the one that I gave earlier on, and I hope you'll appreciate that. I hope you'll appreciate the intricacies of algebra that are involved in proving that the limit of x squared as x is approaching 3 is equal to 9. So this is a proof, okay? So we want to find delta such that if x minus 3 is less than delta, then x squared minus 9 is less than epsilon. So we always start from here going to the delta. So our fx is what? Our fx is x squared. So it's x squared minus l, which is 9 less than epsilon. So now we perform the algebraic manipulations that go with it. So you can clearly see that this is a quadratic expression, so we can factorize it. So it's x minus 3, x plus 3 less than epsilon. Now notice that our x minus a from the definition, by the way, from the definition, remember it's x minus a less than delta. So in this case, x minus a is what? Is x, it's x minus 3. In this case, it's x minus 3. So take note of this. This is what we want. And we want to remain with this x minus 3. So the x plus 3 is a little bit in the way. Right. So let's perform some maths from basic mathematics. You must have picked this up there. So I'm going to explain why that is. So go back to your basic mathematics to understand why I've done that. So I want to remain here with x minus 3. Because the x plus 3 is in the way. So I'm going to divide both sides of the inequality by x plus 3. So it's going to leave me with epsilon over absolute value x minus 3. And this is my delta. But I have a bit of a problem here. My delta cannot have x. Why? Delta cannot have x because my delta needs to be a constant and x is a variable. So I need now to find a way to deal with my x, which is getting in the way. Right, so what do? There's a simple procedure. First of all, we just need to replace, right? So first of all, we need to replace this absolute x plus 3 that's getting in the way with a constant, right? We need to replace it with a constant value so that we can have so that we can determine what the value of delta is going to be. Right, now there's a trick. I won't go into the intricacies of the trick. All I can tell you here is that we always choose our delta, right? We always choose our delta to be less than 1. Don't ask me why it's less than 1, because I'm not able to go into the detail here because I need to make the video as short as possible. Right, so now, since we want our delta, which is this delta here, right? This delta here, we are saying we want it to be less than 1. Okay, so if this delta, we want our delta to be a value that is less than 1, which means even on the left-hand side here, we also want our absolute value of x minus 3 to be less than 1 as well. So now we assume that x minus 3 is less than 1, which is a straightforward inequality which can be expanded. Something that you also know from, this is minus 3. Something that you know from basic mathematics. This is, x minus 3. Sorry for the shortness there. But now we want to be left with x standing alone in the middle there. So we need to add 3 right through. So if we add a 3 right through, then it means 3 minus 1 leaves us with a 2. And voila, x is now standing alone. 3 plus 1 gives us a 4. Now, what we want to do here, the trick really is to recreate this. So let me put this in a cloud. We want to recreate this by playing around with this inequality. So at the moment, in the middle here, we've got x, but we want to have x plus 3. So a good starting point will be to add 3 to both sides. So x plus 3 here, so 3 plus 2 gives us a 5. And 3 plus 4 gives us a 7. Now we've got x plus 3, but here's absolute value. So I can just make it absolute by just plugging in the absolute sign there. Then now it's looking nice. But in order to achieve this now, because notice here our absolute x plus 3 is a denominator. Here it is a numerator. So what do? Simple procedure is to find the reciprocal of both sides. So this then becomes finding the reciprocal. This now becomes 1 over absolute x plus 3. And on the other side is 1 over 5. Beautiful, beautiful, beautiful. If you're confused, just a bit of revision on this to understand why I did it that way. So what is missing now? What is missing is just the epsilon. So if I now multiply everywhere by epsilon, then it means I end up with what? With epsilon over 7 less than epsilon over x plus 3 here, and epsilon over 5. And voila, this now looks exactly the same as our delta here. So all these values are deltas. So we like to work with the smallest delta, of course. So now we need to choose our delta so that it is the smallest delta between these two values. We pick one. The smallest here is epsilon over 7. But remember, our assumption, we made our x minus 3. We said our delta will be less than 1. So we must not forget our 1. So obviously, we now choose our delta to be epsilon over 7, which is the smallest number there. Now, the next step is very simple. Right, the next step is very simple. Now, we need to remind ourselves of the assumptions that we made. So the first assumption, we say that x minus 3, we said it would be less than what? Remember, there were two values. One, we said, remember when I said delta is the minimum of what? Of epsilon over 7 and 1. So the first assumption is that this absolute x minus 3 is less than our delta, our first delta, which is what? Epsilon over 7, and x minus 3 is less than 1. But then we also have x plus 3, the absolute x plus 3. It is less than what? Let's go back to where we did this and look what x plus 3 is less than here, and here it is. So x plus 3 right there, it is less than 7. So there we are, it is less than 7. So now we've got the three conditions to work with. So let's go back now to our fx minus L. Remember what we did the first time. What did we do? We factorized this thing here, yes. So now we need to find the values. This one must be less than x minus 3 here. So it's less than what? It's less than epsilon over 7. So it's less than epsilon over 7. And this one is less than what? It's less than 7. So what does 7 in numerator and 7 in denominator do? They cancel each other out. And voila, what do we get? We end up with what? Epsilon. So we have landed back at this because we needed this. We needed to end up with epsilon, and that's exactly what. So if you go back to the original definition, we say x squared minus 9 here. Absolute x squared minus 9 is less than delta. So we've literally reversed. So we are done with the proof. So all that is left is just to give a conclusion and say what needs to be said, which is exactly that. So